Alrighty, so we have number 7 coming our way. We've got a couple is determined that they need $1 million in a retirement fund when they retire in 35 years. How much money should they deposit at the end of each month in an investment that pays 10% interest compounded monthly to reach this goal? And how much money would they have when they retire if they were to add $100 to this planned monthly payment? And so again, I am going to add some questions to this, everyone, just to help make meaning of it. And I will speak to those as I go through this example, so yours will look different than mine does. So they want to have $1 million in a retirement account, which is not unrealistic. I'm on track to be at about $2 million in my retirement account myself, and so is my wife, as I said in a previous lesson. This is going to be in 35 years for these people, and so the interest rate is 10%, and M is going to be compounded monthly, so 12. I is R over M, N is MT, so 0.10 over 12. That's going to come out to be a repeating decimal, I believe, so I'm going to leave it as a fraction. And MT is 12 times 35. And I'm going to have to do the math on that one real quick here. 420. So I think we have everything that we need to go ahead and put this into the formula. So we've got the $1 million equals, and I wrote that too high. I'm going to end up crossing over my other formula. I'm going to have to move it down. So R times 1 plus 0.10 over 12 to the power of 420 minus 1 over 0.10 over 12. And so, again, Wolfram is not going to finish this one for me. I'm going to have to do the division at the end myself, which is kind of a pain. Don't know why Wolfram does that. So our S, our future value, is $1 million. We're looking for the R. I need to change that to an X because Wolfram won't like it. I is 0.1 over 12. N is 420. And I is 0.1 over 12. Thank goodness we don't have to do that by hand. I know I've said that a lot, but I'm really feeling that today. Okay, so everyone, we've got 1 million divided by, and stop trying to autofill for me, Wolfram. I need to see the number 3796.64. 796.64. We get $263.39. So to have $1 million in 35 years, pay $263.39 into an account every month. And I am curious total amount that the couple pays to pull this off, everyone. So we've got 263.39 times 12 times 35 is, and I'll write all that out also because I'm trying to figure out how much they invested here. So 263.39 times 12 times 35 gives us 110,000. $623.80. So the couple invested a total of $110,623.80. They gained, I just need to subtract how much they ended up with from how much they invested from how much they ended up with. So 1 million minus 110,623.80. So by doing this, everyone, they are going to gain $889,376.20. So they're making almost $900,000 for doing nothing other than just putting some money in every month. And so the total amount of their money that was put in was 110,000, and by doing that, they gained 889,000. That is pretty awesome, everyone. And then the next piece of this, just to play around with this some more, how much more money would they have when they retire if they were to add $100 to the planned monthly payment? And so let's just take a step back here in Wolfram, everyone. I'm not going to do the SERMTN and all that again. Oh yeah, I do need to, don't I? I need to redo a whole entire problem. Shucks. So let's go ahead and take a look at these guys, and they're asking us the question, hey, how much would I make if I was to add $100 to that payment, because I think I can do more than that. And so the amount of their monthly payment right now is $263.39. So we're going to go to $363.39. The rate is still going to be 10%. The M, or compounding periods, is still going to be 12. And time is still going to be 35 years. So our R over M is going to be 0.10 over 12. And our MT is still going to be 12 times 35, so 420. So what we're going to have now, everyone, so it's taken me a minute to write this down here. So what we are going to have is a situation where we're looking now for the future value. We know what their monthly payment is going to be, $100 more than what we told them they needed to do to reach that goal. And so we've got 1 plus 0.10 over 12 to the power of 420 minus 1 over 0.10 divided by 12. So we'll swing that in Wolfram and we'll see what we end up with. So 363.39, and the I is 0.1 divided by 12. N is 420. And again, I is 0.1 divided by 12. So they would end up with $1,379,660. And so the additional $100 per month. And the end down there is 420, so that would end up being about $42,000 more that would go into the account, everyone. I think really quickly, let me just do some fast multiplication here. Yeah, 42,000 is how much more they would be adding to this, the amount that they're investing. The additional $100 per month would result in a final value of $379,660.30. So they would be up by doing this by about almost $400,000 above what they were to begin with. So That was a pretty cool problem. I sort of like doing these every one. It's interesting. And if I was to be the person advising this couple, I would tell them, hey, you would be better off to have started doing this earlier with less money than to try and do it now with more money, because time again is the big deal here. And if they had started doing this 10 years earlier with only $100 a month, um, they would be far ahead of where they are now.